Inference about comparing two populations, hypothesis testing. So in this topic, we will learn how to use hypothesis testing for comparing the difference between the means and the proportions. So for the means, we are looking the means, the difference between the means of two independent population and the means of two related population. And the third one is the proportions of two independent population. So from these three, okay, the type of test conducted will depend on the relation between the two samples. The two samples, whether the samples are dependent or independent. So we want to compare between two samples, the means and proportions, and then make an inference about the population. So we are going to use independent samples or dependent samples. Independent samples are those for which the selection process for one is not related to that for the other, and samples are dependent when the selection process for one is related to the selection process for the other. So an example of dependent samples is when we have before and after measures of the same individual or object. So suppose we want to measure the test score for the students before and after joining the tuition class. So we are taking the sample from the same students before joining the tuition class, one sample, and after joining the tuition class, another sample. But the sample is from the same students, so it is dependent samples. When we want to test the difference between two population means, so we will have mu1 and mu2. The population means from population 1, means from population 2. And for independent samples, it's going to be the same thing. We have two-tailed test and also one-tailed test. So the way to write the null and alternative hypothesis is also similar, only that we have mu1 equals to mu2, meaning that population means 1 is equals to population means 2. The means from population 1 is equals to the means from the population 2. And this is two-tailed test not equals to, and when we have one-tailed test, it's going to be either less than or greater than. So if we write H null, mu1 equals to mu2 is also the same when we write mu1 minus mu2 equals to 0, meaning that we bring the right side to the left side. So comparing the means of two independent samples, we're going to use pool variance t-test. Okay, so in pool variance t-test, the test statistic is this formula. So you'll have this formula and you see there is x1, x2, okay, x1 bar, x2 bar, mu1 and mu2. So this is going to refer to the sample mean from the first sample, sample mean from the second sample, and N1 and N2 is the sample size from sample size 1, sample size 2, and you have this SP squared. So what is this SP squared? It is the pool estimate of the population variance. So this is the formula for the SP squared, and we have the degrees of freedom. So for the t-test, we're always going to have degrees of freedom. So before this, we have n minus 1. So here the degrees of freedom for the the means for the two independent samples, meaning the pool variance t-test is v equals to n1 plus n2 minus 2. Okay. So in hypothesis test for the two population means independent samples mu1 minus mu2, it's going to be the same setup for h0 and h1. So this is mu1 equals to mu2, or mu1 minus mu2 equals to 0, mu1 less than mu2, or mu1 minus mu2 less than 0. And this is the upper tail, lower tail, upper tail, and it's going to be this two tail, which is the sign not equals to. So this is the lower tail, the blue shaded area, which is the rejection region, and this is the rejection region, the upper tail, and this is the rejection region for two-tailed test. So you see, this one going to use alpha, this one we're going to use alpha, but this is alpha over 2 and alpha over 2. So the critical value is going to be the same. This is the negative side of the critical value, this is the positive side of the critical value, and then this is the positive and negative, but here alpha divided by 2. So we will reject H null if the test statistic falls in this shaded area, or minus t stats is less than minus t alpha. Here the t stats is greater than t alpha, and here whether it is less than minus t alpha over 2 or it is larger than t alpha over 2. So in this example, okay, a statistician found that in a random sample of 50 cans of paint produced by one manufacturer, the mean drying time was 201 minutes. Standard deviation, the S is 48. And in the second sample, 11 cans, another manufacturer, meaning that sample 1 and sample 2 are independent samples. The mean was 170, standard deviation is 57 minutes. So does this data allow us to infer at 10% significance level, so this is the alpha, that the mean drying times of the two kinds of paints differ? So from this word differ means that we want to know whether mu1 is it equals to mu2 or mu1 not equals to mu2. So meaning here it is an indication of two-tailed test. So we can extract this information, sample 1, sample 2, 15 size, 11 size, and we have this, the first x bar 201, second x bar 170, standard deviation 48 and 57, and we have alpha 10% or 0.1. And there is no information about mu1 and mu2, so we are assuming it's going to be 0. And then since both samples are independent samples because it is two different manufacturers, so we will proceed with the t-pool variance test. To proceed with the hypothesis testing is using the same steps, meaning the first step is to write upstate the H null and H1. So here the difference is this, mu1 and mu2 is the same, so the difference is going to be 0. Mu1 minus mu2 equals to 0, and mu1 minus mu2 is not equals to 0. We have the alpha, and we need to get the test statistic and also the critical value. So if we refer to the test statistic, the formula will be x bar 1 minus x bar 2 minus mu1 minus mu2 over the SP squared. So we need to calculate the SP squared. So this is the formula for SP squared. So looking back at the formula, the test statistic here is x bar 1 minus x bar 2. So it's going to be 201 minus 170 minus, this is mu1 minus mu2. So from the null hypothesis, mu1 minus mu2 equals to 0. So minus 0, you are left with only x bar 1 minus x bar 2. And you have here the pool estimate of the population variance. So we need to calculate the SP squared, and this is the formula for the SP squared. So once you calculate the test statistic, which is 1.504, you need to find the critical value. So since this is using t distribution, so we need to have the degrees of freedom and also alpha. And here alpha is going to be, two-tailed test is going to be 0.05 because alpha is 0.10. So alpha over 2 is 0.10 divided by 2, which is going to be 0.05. And the degrees of freedom is not n minus 1, but it is n1 plus n2 minus 2, so you're going to have 24. So by looking at the t table, you'll find The critical value is 1.711. So it is plus minus because it is two tails. So one of the values is positive, another one, the left side, is going to be negative. So then we need to compare the test statistic with the critical value. So since 1.504 is lesser than 1.711, so meaning that we fail to reject or do not reject H now because it lies in the acceptance region. So the conclusion is that there is not enough evidence to infer that the mean drying times of the two kinds of paints differ.